for bacteria and you degrade it. So it's a trade-off. There was a trade-off from dispersing offshore versus letting the oil come onshore, and that will be debated for many years to come, whether it was a good idea or a bad idea.
Yeah, and I know the EPA tested the toxicity of this, and it was moderately toxic to 2 different species of organisms in the Gulf. Clearly, oil itself is more toxic than the dispersant, the EPA said, but obviously the dispersant itself did carry some toxicity as well. And Pete, did you want to add something about that?
And by the way, you can't test it for all the organisms, so you always use 2 indicator organisms,
right,
whether they're right, and they were not subsurface organisms. So we don't know the toxicity subsurface.
Yeah, I have a few things to add, as you might expect. First of all, the organisms weren't necessarily organisms in the Gulf. They were sort of Cereodaphnia and this and that are standard EPA test bioassay organisms. These are kind of like lab rats. You can't kill them with a stick, but they're good for living in the lab so you can run toxicity tests. They were short-term toxicity tests, testing only acute toxicity, not the chronic exposures that we've recognized in the Exxon Valdez are critical. The chronic exposures to some of these toxic components don't necessarily kill, but they affect behavior, they affect growth, they affect reproductive output. These have a longer time frame to exhibit themselves in the system, meaning that those of us who say the oil is gone, things look great, not too many dead things are premature. And furthermore, that hasn't been done in those tests. It will be done. I understand there are tests that are now going to try the right organisms, some at depth, some, those from the Gulf, and over longer periods of time. The other thing about this is, and Ed's answer raised an issue that I wanted to, a bone I want to pick. We make the assumption, a whole lot of people make the assumption, I bet we'd get, you never get 100%, but we get a big percentage if we do a show of hands here in the office and in the crowd, we make the assumption that the application of the dispersant was what led to the massive amount of dispersion of this oil, the breaking up into small bits, the higher rates of biodegradation, the minimal amount, relatively speaking, that got to the surface. Well, the natural physical processes by which this oil and gas mixture was released led to dramatic natural dispersion of that oil. This was under high pressure, in very cold water, that entrained very cold seawater, with dramatic mixing, as that camera showed us day after day. That created a natural dispersion. So the jumping from that to the conclusion that it was addition of the toxic, mildly, chemical to it is not supported by any data that we have. Furthermore, oil chemists say that the mousse that reaches the surface is not something that can be readily dispersed by application of this dispersant. So there goes, I don't know how many million gallons, maybe close to 1. I think it was 1.8 million total that we added of Corexit gallons. There goes a whole chunk of it. Then those who have looked at those films and tried to document whether the Triton prongs of 3 prongs of the dispersant delivery system actually shot into the release or not, come up with a conclusion that it very rarely hit its target, thereby casting doubt. And this falls in a broad general category of why don't we, as a system and as an industry, get together and test response issues. And it's not just the effectiveness of the materials and whether you're getting them in and they're doing something that we're sort of making policy in the absence of. It's also looking at the negative impacts of many of these response actions that we take. And the response actions can be as damaging as they are helpful, such as building berms to protect Grand Isle and doing other things that I can go on about piece by piece that have injury that may be worse than the cure.
Okay, thank you. Let me take another question. The question is, what has happened to all of the skimmed off collected oil and all the absorbent materials, booms, et cetera? The questioner asks, is it a problem somewhere else now? Ed, I guess, or? Obviously, the oil that was collected and brought onto freighters and so, or oil tankers was brought ashore and was produced as oil, I guess. But what about the boom? What about the stuff that was skimmed off, which was, I guess, a very small percentage of the oil? And
all the ships and crew boats that had oil all over them, they were brought in and decontaminated that oil was collected, and I'm not sure where it went from there, whether it was landfill, went to hazardous waste disposal. Don, do you know what? Here's a commissioner down here.
Most of the boom material, absorbent booms were landfill.
Absorbent booms were landfill. The stuff that you couldn't clean up, the deflection booms were cleaned and went in storage. The oil that was skimmed, I'm not sure. By the way, skimming oil allows the oil to be removed from the environment. So if in my way of thinking, if we have a response option, skimming would be the first choice because you're removing oil from the environment and you can recycle oil. In that, so everybody is in favor of recycling. It's easier to say than to do. It's difficult, technically difficult, particularly when you don't get in and get fresh oil. You've got to have skimmers. They got to get out there where the oil is fresh to get it up. But when you burn it, you basically skim it up, but instead of collecting it, you burn it. You're creating a water problem into an air problem. So why not skim it and recycle it? And then, of course, dispersants were only used well offshore. There is a lot of data, despite what Pete's saying, that people went out and monitored the effectiveness of dispersants. I'm not privy to all that data, but I know it was collected. I've seen some of it, and that was part of the incident response. We will find out over the next few years how effective it is, just because we don't know now. Tens of thousands of samples were collected. Only a small fraction of those have been reviewed outside of the incident command. So over the next several years, we will be in the process of looking at how effective were the dispersants. We really don't know right now, and so I hate to say one way or the other, but there were dispersant monitoring programs. There's anecdotal evidence that use of dispersants at the wellhead prevented the oil from coming straight up, which was, of course, where the recovery vessels were. Now, that needs to be validated, but I've heard that from several people in the Coast Guard, that when they did not use dispersant, there were a couple of times they ceased using dispersants at depth, they had a vapor problem at the surface. So all of this picture needs to be put in place. We don't know with any certainty a lot of the details yet. A lot of the data was collected, massive amounts of data. We don't know how much oil is on the bottom. I personally looked at maybe 100 or 200 samples, sediment core samples, and there's not black oil in those samples. There are trace levels of polycyclic aromatics. The highest concentrations are within a couple of miles of the wellhead. They're on the order of 10 to 50 parts per million total PAHs in the wellhead. So there's not a black layer of oil on the bottom of the Gulf of Mexico. There's a black layer of oil on our coastal marshes where they got impacted.
There is a brown layer of goop at the
bottom. There's a brown layer of goop that cannot be fingerprinted to the oil. And again, this is data that's been collected. We're still trying to figure out what all this means. So for me to stand up, or anybody else to stand up and say we've got anything close to a comprehensive idea, we don't.
Yeah.
But having said that, I looked at a couple of hundred samples, and there's not black oil in those samples yet. We may find some, but knock on wood.
Right. The carbon, of course, the carbon is still out there, and it'll be really interesting to see how that cycles through the ecosystems, because it may not be oil anymore, but it's certainly a big load of carbon. Let me turn to Wes and ask about the data question here, because you mentioned that the sort of the tragedy of Ixtoc was that basically the research dollars dried up right away. Do you have a sense, I don't know if anybody has a broad enough encyclopedic sense of whether there's been enough research money spent here to now and looking down the road to really be able to look back in 10 years and say, we really do understand what the impact of this oil spill was?
I think that we're on the track to doing the right thing now. There have been more samples taken, like Ed showed. If you've ever gone to the NOAA website and seen the NERDA by the numbers little chart, 30-something thousand samples taken. It's just huge numbers. And then academic research, NSF put out 40 or 50 rapid grants right away. BP has promised the $500 million in Gulf of Mexico Research Initiative. 40 million of that has already been put out. We're hoping in the community that we'll see the RFP for the next 50 million. It's to be 50 million a year for the next 10 years. If that works out, it'll be unprecedented for the knowledge that we'll learn from this spill. And so I'm hopeful that good things will be coming for the research community. EPA and NOAA, NSF, all of these have plans for research opportunities.
Yeah. Pete, do you want to add something quickly? And I want to get to more questions.
I do quickly. And that is to say, a lot of what we wanted to know, we didn't have the money at the time in state hands or in federal hands to go out and learn it. We also didn't have the plans in place or the research platforms, the submersibles and the other ocean-going vessels to look at it. Remember that the dispersal, while successful in one sense, not sending oil to the shore, made it available to suspension feeders throughout the water column, and that we needed to be out there to look at. We may cleverly now know things about food chains and use higher trophic level organisms that we could trace back to problems that happened lower in the food chain, but that's a little dicey and needs some people smarter than me to do it.
Okay, next question. What about the dead turtles on the beaches? Were those because of the effects of oil or because the shrimpers knew they had a free pass and stopped using the turtle extruder devices and other precautions? What is known about the turtles? Ed, did you, or Wes?
Well, there's a very strong tracking program for dead turtles coming in. And I don't know the numbers personally for the northern Gulf of Mexico, but there's a certain number that normally comes in. There was a lot of attention obviously paid to them. They're part of the charismatic megafauna, as we say. And so there were turtles that were brought in that were oiled, some that died eventually, some that were oiled, cleaned, and released. There were others that washed in dead that didn't have any oil on them at all, and they're probably a part of that natural cycle that we see each year. And so the numbers are still not clear where they're going to wind up.
Okay. Here's a question. Somebody mentioned this a little bit already, but do you believe that the emergency creation of the barrier islands off the coast of Louisiana was useful, positive, or negative impacts? You want to take that, Ed?
Next question again. The governor and people in Plaquemine Parish have taken a lot of criticism, and a lot of it is correctly placed. But the house was on fire. You got to remember, back in May, in the middle of May, we went from 1,000 barrels a day to 5,000 barrels a day to 12,000 barrels a day to 19,000 barrels a day, and it was heading up exponentially. And the experience in the Exxon Valdez was that there was a black tide that came ashore. And that's all those people down there saw, was a black tide of oil coming ashore. And so they said, gosh, we've got to do something. We put booms everywhere, which were virtually ineffective. And somewhere in all of this melee, the idea of building the sand berms came up. And apparently they have been used effectively in certain parts of the world. I don't know anything about that. But I'm going to not be as critical as some folks. The house was on fire, and we didn't know what. Now, some of us didn't expect a black tide to come ashore, but we weren't consulted by the governor. So I'll just let it sit at that.
Okay, that's good. And here's a question for you, Wes. What do we know about the impacts on bluefin tuna and other species reproducing in the area at the time? I guess it should be said that the bluefin tuna, they aren't fished in the Gulf, but the larvae, I guess, are developed there, and then they expand out through the Atlantic Ocean, right? And so
yes, that's correct. In fact, they have two places they spawn, one over in the Mediterranean and one right where the oil spill took place. So there's huge concern among the scientific community about the bluefin tuna and the eggs that may have been impacted there. It's a long-lived species. And if you take away a year class, it's not that you just lose that. It could be a decade or more before you see the repercussions of that. So that is a real species of concern, and time will tell us what actually happened in that.
Yeah, and I guess obviously they're under huge pressure from overfishing anyway. So it's a species that's in grave danger to begin with. I actually, just by coincidence, had